In this episode, we connect AI security to a well-known security tradition, the habit of naming the most common risks and building practical controls that actually reduce them. The Open Worldwide Application Security Project, OWASP, is a community that has long helped teams understand top risks for web applications, and in recent years it has also published guidance focused on large language model systems. The value of OWASP-style guidance is not that it predicts every possible attack, but that it gives you a shared vocabulary and a set of repeatable defenses for the risks that show up again and again. For beginners, this matters because AI security can feel overwhelming, like there are infinite ways things could go wrong. A top threat lens makes it manageable by pointing to patterns, such as prompt injection, data leakage, and insecure integration design, and then pairing those patterns with controls you can explain. We will keep this high-level and beginner-friendly, focusing on what the threats mean in plain language and what kinds of controls reduce them without turning the system into a fragile maze. Before we continue, a quick note. This audio course is a companion to our course companion books. The first book is about the exam and provides detailed information on how to pass it best. The second book is a Kindle-only ebook that contains 1,000 flashcards that can be used on your mobile device or Kindle. Check them both out at cyber.author.me in the Bare Metal Study Guide series. One of the most important threat patterns for LLM systems is prompt injection, which is when untrusted text influences the model to ignore your intended instructions and follow the attacker's instructions instead. You can think of it as someone slipping a note into the system that says, "Forget the rules and do what I want," and the model mistakenly treats that note as authoritative. Prompt injection is especially dangerous when the model processes external content, like emails, documents, or web pages, because attackers can hide instructions inside that content. Key controls here include strong separation of roles, meaning the system clearly distinguishes between system rules, user requests, and data being analyzed. Another control is input handling that treats retrieved text as untrusted, with guardrails that reduce the chance the model will interpret it as a command. You also reduce risk by limiting the model's ability to take action based on what it sees, because injection becomes more damaging when the model can trigger tool calls or retrieve sensitive data automatically. The security mindset is that the model is not a secure parser of intent, so you build boundaries outside the model to prevent one piece of text from becoming a master key. Another major risk pattern is sensitive information disclosure, which is when the system reveals data that should not be exposed. This can happen in obvious ways, like repeating a secret that appears in the prompt, but it also happens in less obvious ways, like leaking internal document content through summarization or revealing details from conversation history when sessions are not properly isolated. In LLM systems, disclosure can also happen through retrieval, where the model is fed content from internal repositories and then outputs it to a user who should not see it. Key controls include enforcing authorization outside the model, so the model never receives content the user is not allowed to access. You also use data minimization, meaning you pass only what is needed for the task rather than whole documents by default. Output controls matter too, such as redaction for common secret patterns and policies that prevent the model from repeating certain types of data. A simple rule to remember is that you cannot leak what you never provided, so secure design focuses on controlling what enters the model context. A third pattern is insecure output handling, which sounds abstract until you realize that model output often gets placed into other systems. If the output is displayed in a web page, stored in a database, or sent to another service, it can become an injection vector in its own right. For beginners, it helps to think about how a malicious user might try to make the model generate content that breaks something downstream, such as output that looks like a command, a script, or a structured payload that another system might misinterpret. Even without getting technical, the key idea is that model output is untrusted content. Controls here include output encoding and sanitization appropriate to where the output is going, as well as restricting output formats when the destination is sensitive. If you expect a short summary, you should not accept an output that contains unexpected structures or long blocks of text. Another control is to separate generation from execution, meaning model output should not be directly executed as code or treated as a trusted instruction without validation. This is the same security principle you apply to user input, but applied to AI output because AI can be manipulated to generate harmful payloads. A closely related risk is excessive agency, which is when the model is given too much power to act. This often happens when systems add tool access and allow the model to call functions like search, email, ticket updates, or data retrieval without strong controls. The threat is not only that the model might be tricked by an attacker, but also that it might make a wrong decision under ambiguity and still take an action. Key controls include least privilege for tool credentials, meaning the model can only perform the minimum actions needed. Another control is scoping, meaning the model's tools operate only within defined boundaries, such as a limited dataset or a restricted set of operations. Human approvals become important for high-impact actions, and audit trails become essential so you can reconstruct what happened. A beginner-friendly way to summarize this is that the more the system can do, the more carefully you must constrain it, because a single bad prompt or bad inference can cause real-world consequences. Another threat pattern highlighted in LLM guidance is over-reliance, which is when users treat the model's output as truth or as policy. This is not a purely technical vulnerability, but it has security impact because it leads to poor decisions and unsafe behavior. Over-reliance is amplified by the model's confident tone and by the fact that it can produce plausible answers quickly. Controls include user experience cues that emphasize the model's role as an assistant rather than an authority, especially in high-stakes contexts. You can also build in requirements for verification, like showing sources for retrieved content or requiring human review before customer-facing actions. Training users to recognize uncertainty and to treat model output as a draft is part of the control set. For exam purposes, it is important to recognize that security is not only about blocking attackers. It is also about preventing normal users from making mistakes that attackers can exploit. A system that encourages blind trust creates opportunities for manipulation and error. Supply chain and dependency risks also show up in AI systems because you rely on external models, libraries, and services that can change. If a vendor updates a model without clear versioning, your safety posture can change overnight. If a library has a vulnerability, it can affect your model service even if the model itself is fine. Controls include version pinning where possible, monitoring advisories, and maintaining an inventory of components. Change management and staged rollouts are important because they let you detect unsafe behavior shifts early. For AI specifically, you want regression testing that checks safety behaviors, not only functional behaviors. The main lesson is that your system is an ecosystem, and an ecosystem's security is only as strong as the weakest changing component. OWASP-style thinking encourages you to treat dependency management as part of your threat model rather than as a background detail. Another risk pattern is denial of service and resource abuse, which is especially relevant when models are expensive and have variable compute costs. Attackers and even curious users can send oversized prompts, trigger long outputs, or repeatedly call endpoints to drive up cost and degrade performance. Controls include rate limiting, quotas, input size limits, and timeouts. You also design graceful degradation, meaning the AI feature can be temporarily limited without breaking the entire application. Monitoring is crucial so you can detect unusual usage patterns quickly. For beginners, the key idea is that availability is part of security, and models create a new kind of availability risk because they can be costly and slow compared to traditional endpoints. Protecting the model service is not only about preventing data theft, it is also about preventing resource exhaustion that knocks the service over. When you put these threats together, you get a practical set of key controls that map cleanly to secure design decisions. You treat all inputs as untrusted, especially external content, and you build boundaries so untrusted text cannot override system rules. You enforce authorization outside the model and minimize the data the model sees. You treat outputs as untrusted and encode or sanitize them for their destination. You restrict agency, scope tool access, and require approvals for high-impact actions. You manage change with versioning, testing, and rollback, and you protect availability with limits and monitoring. This is the spirit of OWASP guidance: common threats, practical controls, and repeatable habits. For a beginner, The most important takeaway is that LLM risks are not mystical. They are patterns that resemble classic security issues, like injection, data leakage, and overprivileged access, just expressed through natural language interfaces. If you learn to name the pattern and pair it with a control, you are already building the core competence that this certification expects.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit baremetalcyber.com.